Hello scholars. Today we're going to look at a different form of quadratic equations, and we call this form the vertex form. And the reason that we call it the vertex form, sometimes it's also referred to as the transformation form, is because when we write this in the form y equals x minus h squared plus k, it turns out that the two values h and k form the vertex, and that x equals h is the axis of symmetry. So if we see equations in this form, we should be able to pick out the values of h and k, and then take a look at the vertex and the axis of symmetry. So let's take a look at the first one. The first one, in number 1, you can see that the value of the equation, if we rewrite it in terms of x minus a -4, notice that h is going to be -4 and k is going to be -2. So the axis of symmetry is x equals -4, and the vertex is -4 and then -2. In the next equation, I'm just rewriting this so that you can see that the value in front, a, is negative. Remember that will tell us that the parabola opens down, and the h is +3 and the k is 0, so the vertex is 3, 0, and the axis of symmetry is x equals -3. In the next one, we don't need to really rewrite that because we can see that it's x minus 5, so h is 5, and k is -4, so the vertex is 5, -4, and the axis of symmetry is x equals 5. In this next one, number 4, it might be a good idea to think about rewriting this as, notice that there is no h here, and so that's why it looks like just x squared. There's no parentheses, but if we expand it to write it in vertex form, you can see that h is 0, so that means that the axis of symmetry is x equals 0, and the vertex is, again, h and k, so 0, 3. So now that we've identified the axis of symmetry and vertex in that form, now let's look at how we can apply and graph this. So we've been given the equation, and notice that the first thing we'll do is sort of separate out the h and k. So h is -2, so that means the axis of symmetry is -2, and the vertex is going to be -2, 7. So if we use our graphing calculator to fill in the rest of the values, notice that this is going to remain upside. It is going to open upside down. And then just as a characteristic, notice that the domain is going to be all real numbers again, and then the range is going to have a maximum at 7, so we're going to write it as -∞ to +7. Okay, in the next example, notice that again in this case h is +1 and k is 0, but notice that we have a multiplier in front 3. And so again, if we look at the vertex, which is going to be 1 and 0, and we place our parabola on there, notice that again the domain and range, the domain is going to be all real numbers, and the range is going to have a minimum at 0 for that one. So what we've noticed here is that these parabolas in this vertex form actually are quite simple if you can identify the values for a, h, and k. And so the most basic quadratic that we have is the y equals x squared, and we call this the parent function. So the vertex form really is what we call a transformation function, because it transforms not only the size but the position of the parabola. And so all of these values, a, h, and k, they all change a different, they'll have a different effect on the parabola. So let's take a look at a few more of these and see what happens to these, and then we're going to note what the transformation is compared to the y equals x squared graph. So you can see the y equals x squared graph is given to you for that, and we can see that. So the first one we're going to write in vertex form, and you can see that the vertex is going to be -2, 0. And so we'll go ahead and fill in the rest of this parabola. And notice that this parabola has really been, all it's done is it's shifted to the left 2 values. All of those values, if you look at where the y equals x squared started, it is shifted to the left 2. So if we look at the next one, notice that this is x squared plus 5. So again, if we rewrite it in vertex form, you can see that h is 0. So so h, we haven't done any change with that, but k is 5. And so again, the vertex is going to be 0, 5. And if we again use our graphing calculator to give us the other values, notice that this has just been a shift up of 5. So if we look at the next two, again, if we think about this value as h being -1 and k being -6, but notice it turns out that it's x plus 1 because of minus and negative. And so again, if you look at the vertex is -1, -6. And so if we look at how this parabola has been transformed, notice that it's been moved to the left 1 and down 6. So if you can really look at each of the points, but pay attention closely to the vertex, that is where you want to focus your attention for that transformation. And the next one, you can see the vertex is 4, 1. This one is going to be open down. So if it's open down, we're going to refer to that as a flipped transformation, or we say that it's reflected over the x-axis. Notice this one has also been shifted to the right 4 and up 1. So you're getting the sense that how these are transformed. Notice the connection between how they're shifted horizontally and how they're shifted vertically, and these numbers are coming up in the equation for each of those. So we have a couple more examples just to get an idea of, again, pay attention to the transformations here. So if we look at this in vertex form, notice that h is 0, k is -7, and the number out in front is 3. And if we look at the vertex is going to be 0, -7. We fill in where the rest of this parabola is, and notice that this value this parabola is quite narrower than the original, and we'll call this a stretched, or we'll say that it's narrower. And notice that the vertex has also just been shifted down 7. It has not been moved left or right, it just moves straight down, but it is a lot narrower. And the last one sort of has a lot of different things going on. Notice that the -1/2 in the front is being multiplied, and then you can see that h is 3, k is -2, so the vertex is 3, -2. And so this also has been flipped upside down, but notice that this is wider. So when we say that it's wider, we refer to that as being compressed towards the x-axis. Okay? And so not only is it compressed, but it's flipped, and it's shifted to the right 3 and it's shifted down 2. And again, notice where the vertex is compared to the original. The original parent graph is always at 0, 0, so that's what we're looking for with those. So let's put this all together then. If we put this all together, notice that h has actually, it shifts the parabola horizontally. And if you look at anything that's plus inside the parentheses is a shift to the left, and anything that is a minus is shifted to the right. K moves it vertically. So if you see anything that's plus k in the equation, that's going to shift it up, and anything that's minus k is going to be shifted down. Now remember that if a is negative, that tells us that the parabola is opened down, which we call it a reflection over the x-axis. You can also say flipped. And remember that if a is greater than 1, if we have a larger number being multiplied, that we're going to call this a stretch or narrower. And if it's less than 1 but greater than 0, so if it's a fraction, we're going to say that it's a compression. So the idea here then is for us to be able to take each of these transformations and then actually go backwards and write equations for them. So we're going to write these in the form at the top here. So y equals a times x minus h squared plus k. And we're going to look at what they've asked us to do. So they've asked us to take the parent graph and move it 2 to the right. So horizontal transformations are h. So that means we need to make h as minus 2. So notice that we're going to make that a minus 2, and that's going to give us just minus 2 squared. Notice here that this is not there's no k that we have to add. You could put plus 0, but you don't need to for that. So that's going to be the function we're looking at. So notice the next one, this is going to be 5 units up. So that means that we have to use k as our transformation, and h is not doing anything. So we're going to write it as x squared plus 5. The next one is if you translate it 3 units to the left and 4 units down, now there has to be movement with h and k. So in this case, think about translating it. And so if we think about to the left, that's going to be x plus 3, and if we move it 4 units down, that's going to be a minus 4 for the k on the outside. So I want you to see the connection between the numbers left and right and the numbers up and down. So those are going to be this one. So try the next one on your own, press pause, and see if you can find the value there. So translating it 6 units to the right and up 4, that's going to be, if we think about this, this is going to be x minus 7 squared, and then it's going to be plus 4 because that will shift it up plus 4. The next one you can see has been reflected over the x-axis, which means that the a has to be negative, and then it's translated 3 units down. So we're going to think of this as the negative 1 gets multiplied out in front, and this is going to be x squared, and then the minus 3 is the k. So I've underlined the I've underlined the values in this next one here, so that we can see those. And if you think about this as reflected over the x-axis, it's moved 5 to the right, so that means that h has to be minus 5, and then it has to move 2 units down, so that means k has to be negative 2. So when we write this as a vertex form, we get x minus 5 squared minus 2, and then we have a negative 1 out in front, so it's negative 1 times x minus 5. All right, so then the last two are a little bit challenging. There's a lot going on here, so let's take a look at those first. And so first, they've given us the vertical it's vertically compressed by a factor of 1/3, which means it's going to be multiplied by 1/3, and it's translated 8 units up. So there's no shifting left or right, so h is going to be 0. So we end up with positive 1/3 times x squared plus 8. And the last one, you can see it's vertically stretched by a factor of 2. It's reflected over the x-axis and translated 4 units to the left. So if it's stretched by a factor of 2, that means we multiply by positive 2, but it says it's reflected, so that makes it a negative 2 for a. And then you have x plus 4 squared because it's 4 units to the left, so it's x plus 4. So when we look at these vertex form, pay attention, close attention to what A, H, and K are. Again, if you need to rewind and watch a few of those again, you certainly can, and then we'll practice these when creating them in vertex form.